Hey, welcome back. So today is day three, learning about Tinkercad. Today what we're going to be working with is programming with code. So we're going to be using code to do some things. And we're just going to kind of have some fun. We're going to do some kind of advanced things. We're going to work with an LCD screen and some servos and write some code. As always, I'm here with my trusty camper, McKinley. You ready to go today, McKinley?
Yep.
All right, let's see what we're after today. So today we're going to be playing with an LCD that stands for Liquid Crystal Display and Servo Motors, and we're going to be writing some code. I've got a breadboard that I just built up with the example in here. Now, what my screen is doing and what my breadboard are doing are kind of like different stages of the project. This stage is where you turn a potentiometer to turn the servo motor. Almost no way you can see the servo motor that well, but who knows, cameras are really good these days. So as I turn this potentiometer, it's going to turn the servo motor. You can also see, if you can see the LCD screen, that it's showing you what the potentiometer reading is, and then also the number of degrees of the servo motor. So that's what we're after today, is to learn about potentiometers, analog readings, LCD screens, all kinds of fun stuff. So what you're going to need to do is you're going to need to go back to your Tinker dashboard, Tinkercad. Make sure you're not in 3D designs. You're in your circuits area. And we're going to create a new circuit together. So go ahead and click on Create New Circuit. Hopefully you've kind of played around with some things in Tinkercad. Maybe you've broken a thing or two, but that's okay. It's all for learning. That's part of the maker spirit. So the first thing I'm going to do today to start things off is I'm going to rename my project. I'm going to call it Fun with LCDs and Servo Motors. Now, normally what we've done to start things off is we've added a breadboard, and then we've also added an Arduino Uno. I was clicking on them just to kind of show you what they were, but I don't actually want to add them yet. But today what we're going to teach you a little bit about is the starter projects. So where it says components basics, switch it to say starters, and I'll tell you what, we'll just say starters all. So components are individual pieces, and then you build them up to make things. But starters are neat little circuits that you can just kind of like bring over and see like a whole big thing, right? I mean, I'm tempted to like bring over a whole bunch of them. Starters are fun, right? Like you could definitely spend the better part of an afternoon just looking at different starters. So this is not the starter that we're going to do today, but this is LEDs that are connected to an RGB LED at the top. All kinds of different things you could do, right? So that was just kind of an example of a starter. Now I'm going to click on undo. Hopefully that just goes away. But I could go through here and I could play with all these different starters. I'm tempted to do them all, right? This one is a proximity sensor. That was the word I was for. And so when things move in the field of vision, the LED goes off. So fun to play with these things. But today, the one that we're looking for is the one that has an LCD screen on it. So go down through the starters until you kind of see one. Oh, these look so fun. Until you see one with an LCD screen on it. There it is. There's our LCD. And let's go ahead and drag it over. You can drag it over, or the way Tinkercad works best is I think if you click on it, then click again, it pops over. It does take it just a second to pop over, so don't like touch anything while it's bringing it over. And so the nice thing about this is they did a bunch of the wiring for an LCD for us, which is nice. Wiring up an LCD, there's a standard protocol for it. It's not hard. I'll talk about it just a little bit. But I mean, I wired up my physical one here. You could totally do it. It just takes a lot of wires. I'm going to describe the most important parts of it. So the most important parts of it, there's power and ground to the LCD. Those are the first two. Actually, it's ground, then power. The next one is your contrast pin. So I've got my contrast pin set up over here. And what the contrast pin lets you do is it lets you change the text of like how much contrast there is in your LCD, right? And so it's very useful on a real circuit, but in Tinkercad, it's not that important, right? And then after that, there's 7 different control lines. So here's 1, 2, I guess this one's just grounded, 3, 4, 5, and 6. So I guess that was my 7th that was grounded there. And then there's a backlight on it, which is just an LED, which is on here. So really, it's just power, ground, a contrast, 7 control lines, of which one of which is grounded, and then a backlight. And then in your code, so let's go ahead and look at the code that they added for this guy. You'll notice that the code here jumps straight into text. And that's because, like with blocks, it's kind of annoying to do this code, right? So let's go ahead and glance at this code and kind of figure out what's on here. So the first part of this code is what's called a comment. So everything that's kind of like light gray here is a comment. Now comments are all well and good. It gives credit to the authors and things like that. But I kind of don't want them. So I'm just going to delete all the comments, just because it'll make my code a little bit cleaner. The next comment is another style of comment. This is a // Again, it's kind of this brown color. Anything that's a brown color is just a comment. It can get deleted. Now you do have to be careful when you're deleting, that you don't want to just kind of get haphazard with deleting and delete things that are not comments. But it's a comment here. I'm going to see if I can make my font a little bit bigger for you. Maybe if I do this, it'll get bigger. Yeah, that works. And so we're going to include this library. Arduino is really big on libraries. It makes it easy to work with complex things like liquid crystal displays, right? And what you have to do with this library is you have to initialize it to show which pins were connected. So where are those 6 control lines connected? Well, they're connected to 12, 11, 5, 4, 3, and 2. And you can see that over here, 12, 11, 5, 4, 3, and 2. And so that lets us control the LCD. The first thing we have to do is we have to do a little bit of setup. So you have to tell it how many rows and how many columns are there in your LCD. So this LCD, when we start writing to it here, it's got 16 across, and then there's 2 rows. I don't like comments, so I'm going to get rid of this comment just to make my code look shorter. And then it's going to print a message to the LCD. So when we run this program, I haven't done it yet. Maybe you've already done it. It should print "Hello World" right at the top, right? So that's kind of cool. I'm curious. I'm going to try it. So I'm going to hit Start Simulation. So as I start the simulation, sure enough, it says "Hello World" right at the top. Now the bottom line just says 0. Oh, there, it changed to 1. That's kind of weird. I know what's wrong here. I'm just kind of playing. And then eventually it'll change to 2. What it's doing on the bottom, let's look at their code and let's see if we can fix it and make it better. It says set the cursor to column 0 of line 1. So column 0 of line 1, that's the spot right here. So rows, this is the top row, this is the next row, and then columns go this way, right? And what it's saying is put the cursor right there and then print to the LCD some number of milliseconds. So this is how many milliseconds there have been divided by 1,000. So milliseconds divided by 1,000 should be seconds. The reason it wasn't counting in seconds is because of a bug. Let's type some code to fix the bug. So I'm just going to say fix the bug. And to fix the bug, we need to add some kind of delay to this circuit. So type this to fix the bug. Add delay 100, semicolon. So this is the first bit of code we've typed. Typed code is much easier to make little mistakes on, right? So for example, if you spell the word delay wrong, it doesn't work. There's a parenthesis here. Maybe I should make my code even bigger. We'll just hope you can zoom in on there. A parenthesis, and then a 100, and then another parenthesis, and then a semicolon. And if I add that line of code, my simulation should start actually counting seconds quite nicely. So it's kind of interesting that they gave you this piece of starter code. It kind of had a bug in it. The reason for the bug was that on their simulator, it was trying to go too fast and it was getting messed up. So we fixed the bug with that code. So let's go ahead and keep looking at the code that's in here. So it's just counting seconds down there. And what I want to do is I want to delete some of these extra comments just to kind of clean things up a little. And now we can see how relatively short this piece of code is. Now let's make another change. Right now it says hello world on the LCD. Let's go ahead and change it to where it has your name on there. So I'm going to change mine to where it says David Fisher. And so now it says David Fisher, and it's counting in seconds. Another fun thing you can do, we showed this last time, but at any time, if you had a real board, so I'm just going to take my code that I've got right now and put it on my actual breadboard. Like, this is valid code. Like, the simulator isn't a joke here. So now I can make mine say David Fisher, and it's counting in seconds, which is nice. By the way, this fix of the bug isn't necessary on a real board. It's only necessary because of the simulator that we're using. Great, so we're continuing to make improvements, which is kind of fun. So it's just kind of counting away, and everything is going good. Let's go ahead and let's add another potentiometer so that we can display a potentiometer reading here instead. So that's our goal. So let's go ahead and hide the code. And let's go ahead and add a potentiometer. So a potentiometer is not in the starters area. It's in the basic components area. And so I'm going to add another potentiometer. Now I'm going to choose to just plug it right into my breadboard here, because that's how a real potentiometer would work. You just plug it right into your breadboard. And what I'm going to do with this potentiometer is I'm going to take terminal 1 and I'm going to hook it up to power. And I like for power lines to be red. Now here it's just kind of shooting right over the top of all these other things. If that bothers you, sometimes I'm OCD, as you know, right? You can kind of bend it to where you can kind of see that it does in fact go around all those others. So it connects there and there. And then the other side we're going to connect to ground. So I'm going to connect from somewhere in this row. Notice that everything that's connected in this row is all connected together, right? So it doesn't matter if my potentiometer is up there. Everything in this row is connected, so I've essentially taken that leg of the potentiometer and I've connected it straight to ground. Now this middle leg, this is going to be our signal line. So our potentiometer is similar to theirs, right? So it's got power on one side, ground on the other, and then their signal line went here. This went to their contrast pin. Our signal line is going to go over to our Arduino, and we're going to connect it from here to A0, right over there. You can make it any old color you'd like. Maybe I'll go with a nice, lovely purple shade. And then, if you want to bend wires, you can click on the wire, double click it, and you can kind of like move the wires around. So now I am getting a reading from the middle of my potentiometer. And the way this is set up is with the potentiometer fully in one direction, you'll get roughly 0 volts. And then if you crank it all the way the other direction, you'll get about 5 volts. So it'll kind of go between these two rails. So right now I've got, if it's all the way this way, it's getting about 5 volts. So right now it's getting 5 volts to AN0. Now an interesting thing happens. In code, you would probably expect those analog readings to be like between the number 0 up to the number 5, because that's how many volts it is. But in code it's interesting, and this is because of binary. It doesn't go from 0 to 5. It goes from 0, which makes sense, to a number 1023. And 1023 is a special number in binary. It's one less than 1024. And that's just how they work, right? So let's go ahead and play with our code some and see if we can print that reading to our LCD. So I open up the code. So the first thing that we want to do is we want to set up A0 as an analog input. So this is a comment. You can type the comment if you'd like. I'm just kind of saying what we're doing. But the funny thing about this is that it's already done. The default for these pins is that they are analog inputs. So normally you do have to write code to do some setup. But an analog input, it's already set up for you. So there's actually no setup that needs to be done. So we can actually just read the value. Now the way you read the value, I'm going to go ahead and type this down in loop, is you do analog read of A0. You can actually type A0 or just 0. I just prefer to say plain old 0. And what this line of code will do is it will read it. But the way code works is kind of interesting. Reading it, but not like saving it, doesn't do anything. So what I need to do is I need to save it off to a variable. So what I'm going to do is I'm going to choose to, at the start of my program, like before the setup function up here, I'm going to make a variable. This variable is going to be an integer variable. And an integer variable is abbreviated with int. So int is short for integer. And pot reading, pot is short for potentiometer. It's a very common abbreviation. So what I'm going to do is I'm going to take this variable called pot reading, and I'm going to put it in front of my analog read. So it's important to understand what's happening in code. You can see what mine is and you can make yours match, but the important thing is to understand what's happening here. But it's doing an analog read. So like it's getting the value of this pin, and the value is going to be between 0 to 1023. 1023 means it's at 5 volts, and we're saving it off to that variable. Now what I want to do is I'm going to save off that variable. I'd like to see it on my screen. So what I'm going to do is right here, instead of printing out mils divided by 1,000, I'm instead going to do an LCD print of the pot reading. All right, so if I were to run my code now, it would work but have kind of a little bug in it. So let's go ahead and run it and see what happens. By the way, if you'd ever try to run it, I'm going to make an error on purpose. I'm going to leave off this semicolon, right? So if you ever try to run it and you've typed something wrong, it'll say, sorry, it looks like your code has some errors. It'll try to tell you where the problem is, but usually it'll tell you the line after the problem, right? So if you look at the line that they marked, so delay 100, this seems fine to me. Look at the line above it, right? So, oh, I've probably got a problem right here. And sure enough, I'm missing a semicolon right there, right? So just don't be surprised if you see a bunch of red. It's okay. It means something's probably typed wrong. So what we should have going on here, let me see if I can make my screen show up better, is it should be printing, was it not printing? It should be printing the potentiometer reading that's coming from analog 0. Mine doesn't seem to be working. Why isn't mine working? Actually, it looks like what I did is this other potentiometer, at some point I was messing with it. This other potentiometer is the contrast potentiometer, and you can't mess with that, right? Because it'll mess up your display. Okay, so here is, so mine's working. It's got a bug in it still, but it's working. And what it says is it's showing you the value of the potentiometer. And so as I go higher and higher, it's like as I click this more and more, it's going to get farther and farther towards the positive side, and the number is going to get bigger and bigger until it gets to 1023. Now, here comes the bug. You ready? If I go from 1023 down, I'm going to just kind of like click on the middle here, down to like 500. It looks like, so the real value is 511. It looks like the value says 511.3. And that's because that 3 is just still on there from the 1023, right? So the 1023 had the value on there. And then when I went to 511, that 3 is still in there from the 1023. There's a couple ways to fix that bug. One way to fix that bug is to clear the LCD. You can type this if you want, but I'm going to show you a better way to do it. And if you clear the LCD, it'll fix that bug. So now I can go from 1023 down to like 511 and it'll be fine. The problem with clear LCD is that my top line, Dave Fisher, got wiped off, even though I liked having it there. And also the LCD is kind of flashy. So that is one way to fix it, but actually that's not the way I like to fix it. I like to fix it a much lamer way. I like to just print a couple spaces. 2 or 3 spaces should be enough. I'll go ahead and go with 3 to be thorough. And what that does is, let's say that you are displaying a number like 1023, and then, so let me get it up over 1,000 here. And then if you quickly switch down to like 500 and something, it prints the 532 in this case, and then a space, a space, a space, and that clears off those other ones. So that's a very common trick when you're printing to LCDs just to print a couple spaces after. And it actually turns out to be much more efficient than LCD clear, which is kind of interesting. Sissy, how's yours going?
Good.
Is yours working?
I think so.
All right, she's doing great. But I do expect there to be problems. Problems are fine. Pause the video. Hopefully you can look at my code. Hopefully it's big enough now, and you can try to get yours working. So analog readings are neat. We can see different analog reading values, which is cool. But I'd like for this analog reading to do something, right? So I want it to control something. And what I decided would be fun to control is a servo motor. So let's go ahead and see if we can add a servo motor to our circuit. So we've done LCDs, potentiometers. Now we're going to do servos. The servos, you can scroll around. There's two servos in here somewhere for some reason. There's a blue one, and then there's a black one somewhere else. But I want the blue one. It's the only one I see right now, which is good. And so my servo, it's fine right where it's at. Or if you want to, you can rotate it around some. I'm going to rotate mine around to where it's this direction for no real reason. That's just kind of where I felt like doing it. And a servo motor works like this. It's got a signal line, which comes to the microcontroller, power and ground. So power, we know where to connect power. We connect that to our red rail. And then just because I want to, I'm going to choose to make that wire be red. Again, the wire color doesn't mean anything, but it can help make your circuit easier for others to understand. The one that's labeled ground, I'm going to connect to the black ground rail. So I connected ground to the black ground rail, and I connected the middle one, which was power, to the red power rail. Now this last one, which is called signal, I'm going to have to take it over to my microcontroller. And what I'm going to do is I'm going to shoot it. What the heck? I'll just kind of shoot it over the top here. I'm going to go to pin 9. There's nothing sacred about pin 9, but it is one that definitely works. And you can make that color be whatever you want. Maybe I'll use a white wire. Maybe white's not very visible, but you can see that there's my white wire. So I'm going to control this servo motor from pin 9. So it's interesting that, like I said, I was going to control it with the potentiometer, but really the potentiometer goes to the microcontroller and the servo goes to the microcontroller, and that way the microcontroller is in charge of everything, right? So yeah, it's the potentiometer controlling it, but really it's all via the microcontroller. Cool, so that's the wiring that we need to add for a servo motor. By the way, if you ever just wanted to learn about servo motors, we're not doing this now, but I'm just mentioning it. There are some starters with servo motors in here, and you could, so there's one right there, and you could use that as kind of like learning about the code some, but we're just going to do it together. So let's go learn about servo motors. So servo motors are not extremely complex, but they're a little complex. They are complex enough that it's kind of nice to use code that somebody else wrote. So type this with me at the top. So we're going to use code that somebody else wrote. Whenever you use somebody else's code, you have to do what's called an include into your program. And so we're going to say pound, it's just kind of like a little hashtag symbol, pound include servo.h. So the liquid crystal, we got that code for free because whenever we brought in the starter, it gave us the code, but it shows you the style that we need for a servo. And then similar to what we did for liquid crystal, we created a variable of type liquid crystal. So here we created an int variable, here we created liquid crystal, and then right in between the two, I'm going to create a variable for my servo. Not being very creative with names, I'm going to name my variable my servo. So hopefully you can see the format here. It goes, what type of variable is it? And then what's the name of the variable? So this one was a simple int variable. It's what's called a primitive variable type, and it was called pot reading. This one was a liquid crystal variable, and the name of that variable was LCD, and you can see that it's a fancy variable. It can do stuff, right? So it's an object. And then this one is my servo. It's also a fancy variable, and it has stuff it can do as well. By the way, this line right here is what's called a constructor. So we're constructing a variable called my servo of type servo. Now, in the same way that we did things like LCD begin and LCD print, we can do things with My Servo. My Servo has a couple different things it can do. One thing is you can say what pin you want it to attach to. Now, how do I know these magic commands? In fact, I'm not sure that attach is the right word. I'm going to have to go look it up. But the way you know commands like this is through coding reference guides. Now, you can navigate here with me, or you can just watch for a minute. But how do I know that that command is attached? Well, the way you know things is you go to the Arduino reference guide. And I just started typing in Arduino reference and mine auto-completed. And it's got all the different functions that you can use with an Arduino. And it's also got, here in libraries, different libraries that you can use with Arduino. For example, here's Liquid Crystal. Here is Servo. And so if you go into Servo, you can see that it gives you a couple little examples, which are nice. And it tells you what the functions are, like attach and write. You can also read things. And in fact, one of their examples is called knob. This is actually really close to what we're building here. So it's a potentiometer circuit that's controlling a servo. And these examples are great because they'll actually like show you the code to make this thing work. And you'll notice that in their code here, they've got the include line. They call theirs My Servo. That's where I stole the name from. And then they do some other things that we're also going to do, but we'll do it kind of one piece at a time. All right, so let's go back to our code and we'll keep working. So back in our code, we've attached the servo. So we've told this servo object where it's connected to. So it's connected to pin 9. Now we want to do things with that servo. So let's go ahead and in the loop, let's just try a couple things. Let's try my servo dot write. Let's send it to 0 and then wait for a full second. I'm going to type this fast, and then you can get caught up. Oh, servo, I have a little s in my variable name. And then I'm going to do write 180 and wait for a second. I might even wait for 2 seconds here. So I wrote that fast because it's sometimes easier to finish it and then let you pause the video and then type it yourself. So I'm going to say control the servo. So see if you can add that code and then try it out. All right, so let's try it out. So I zoomed in a little bit here. So when I run it, what should happen is my servo should start at 0, so you should kind of like sit there for 2 seconds. And then it should start wiping back and forth, which is cool. And so you can also, by the way, you can try this on a real board as well. So if I take this code and I paste it over here and I put it onto my real board, once it's programmed up here, what should happen is it should just make the servo just go back and forth from 0 to 180. So a servo motor doesn't spin all the way around. They're kind of a different style of motor. They're designed to go from 0 to 180 degrees, just wherever you tell them to go. So there's different types of motors that do different things. And you'll notice that the analog reading is still showing up on my display here, but the servo isn't using it yet. So that's our next goal, is we kind of got a servo that's working and an analog reading that's working, and we're going to put them together, right? Cool, so I'll go ahead and set this guy over here. I'm going to have to unplug him or else he's going to really annoy me. So I'll unplug him there. So let's go ahead and try to get these two things working together. So what I really want to do is I want to take this pot reading and I want to use it to control the servo. Now, if I so I'm going to show you something that doesn't really work. So I'm going to comment these 4 lines out. These were just kind of for my testing, so I'm going to comment those out. What I want to do is I want to just take my servo and write to it the pot reading. I would love to do that. The problem is the pot reading goes from 0 to 1023 and the servo goes from 0 to 180, right? So if I did this, it wouldn't work because it would work at the bottom, right? But as soon as the potentiometer gets up over 180, so as soon as it's like 200 or 300 or 400, right? It's not going to work right. So what we've got to do is we've got to scale the pot reading back. Now, one thing that you could kind of sort of do, this does work, but it's not what we want to do, is you could divide it by some number to make it smaller, right? So if you were to just divide it by some number to make it smaller, that would scale it. I think that divide by 6 would roughly work. You know what? I'm curious enough to try it. What I'm going to do is I'm going to write to the servo, divide by 6, and I'm going to also print out that value just so I know what I'm sending to my servo, and I'm going to give it a shot. So right now it says Dave Fisher 170, and it's 170 because it's really 1023 divided by 6. An interesting thing happens with microcontrollers is 1023 divided by 6 should be a fraction, right? So it should be like this crazy decimal. It just truncates it to the nearest integer value. It's just how it works. So when it's 1023 divided by 6, that should be 170. I haven't done the math, but I'm sure that's how it must work out. And then if I move to like the middle, then my servo follows that. And then if I move all the way up to the end of the range, it goes there. So I can control my servo with this code. And now again, just because I enjoy doing it, I could switch to driving this on a real board as well. So if I wanted to, I could run this on my actual factual board, and I could see the servo moving back and forth as I move the potentiometer, which is kind of cool. So now it's got my potentiometer reading displayed on here divided by 6. And as I turn this knob, you can see that it turns the potentiometer as well. And it actually works pretty neat. Sissy, did you get yours working? Mm-hmm. Cool. So I think that is a pretty neat thing to do. That's almost the end of the exercise for today. Now, there is a special like magic command in Arduino that can do this conversion from like 0 to 1023 to 0 to 180 perfectly, and it's called map. So it's just one of the functions that's built into Arduino. We'll go ahead and try it out. So what we're going to need first is we're going to need another variable. By the way, make sure you always stop your simulation before you try to type. I'm sure that everybody has done this, but if you try to type when you're still in the middle of a simulation, it won't do anything. So I'll tell you what, I'll make a new variable. I'll call it deg. Deg is short for degrees. I could type degrees, but I feel lazy today. So I'm just going to type deg for degrees. All right, so now I've got this new variable deg. And what I'm going to do is I'm going to say deg is equal to map. And what we're going to do is we're going to map that pot reading, which normally goes from 0 to 1023, into a new range from 0 to 180. And so this special function map it's called linear interpolation for you. So take this reading, which goes from 0 to 1023, and map it to a new value that goes from 0 to 180. And now what I can do is instead of doing pot reading divided by 6, which was a pretty good approximation, I'm just going to print out deg, and then I'm going to also use deg to write to my servo. And now what should happen is deg should very accurately go from 0 to 180. Now before it was going from 0 to 170. Personally, that was pretty darn good. But now at 1023, it should go to 180. And then if I go all the way down to 0, it goes there, and it should go everywhere in between. So obviously, map is better than divide by 6. But to be honest, divide by 6 is pretty darn good. Cool. So that is map, and that's actually the end. So I think that this is a pretty good place to call it good. I suppose the final thing I should probably put onto my board, and we should be able to see this thing going back and forth. Now, I do encourage you to play some with this. And so like one thing that I played with, so now it goes from 0, so actually it's at 180 right now, all the way down to 0. Cool. So I do encourage you to play with this. If you remember my solution, I did some other goofing around things. I'd love for you to goof around some more. One thing that I did is I added 3 servo motors, just kind of for goofs. I make them all get controlled by pin 9. You can also, this is an optional extra, you can try to write some code. Here I'm using a for loop that kind of like smoothly goes from 0 to 180. I'm not going to work this with you, but if you did want to do something like this, this is an extra thing that you could build on your own that I would love for you to try to do to make yours better. All right, that's all we got for today. Hopefully you learned about analog readings, potentiometers, LCD displays, and servo motors. We look forward to seeing you tomorrow. We'll do some other stuff. Hopefully you got some good hands-on experience with typing code. I am sure that you made a lot more bugs than me, and you got some practice with debugging. Practice with debugging is super important. So don't feel bad when you see that red. That's you learning, right? So red is good. All right, we will see you tomorrow. Thanks so much for joining us. Bye.